So this is part 2 for lesson 1-3. We're just describing the transformations of graphs. And where we left off was identifying what the A, the H, the B, and the K, what those constants mean. What we also did then was talked about the order in which to do those steps as we transform our graphs. So what we're going to do now is just look at some examples. So example 1 here, I'm going to leave it right there. Okay. As we go through and describe them, we're literally just going to write shifted left or stretched vertically by this. As we do that, the question might be, what order do we write our descriptors in? And I would say follow the steps from up above here for multiple transformations. So you can describe them in any order you want, but it's helpful to put them in the order in which you would actually do the transformations, just to get your mind thinking about that order. So if we do that, we look at step 1, it says horizontal translation. So if we look at horizontal translations, well, let's see, that would be that H factor. So H is right here, it's x minus 8. So we have a shift to the left by 8, or just shift left 8. Doesn't really matter. So we've got 1, 2, stretching or shrinking. Those come from the constant H or B. That's your, I'm sorry, not H, A or B. So if we look at A, number out front, here we actually do have 2 as a constant. So we for sure have a vertical vertical stretch. Now, I will not have room to write all of this, but vertical stretch by, you could say by a factor of, but I'm just going to say vertical stretch by 2. Because remember, our vertical stretch is by a factor of the absolute value of A. A is already positive 2, so we just write 2. Now, it just says stretching and shrinking for step 2 here. What we got to be careful about then is we don't want to forget to look at the coefficient B and look at our horizontal stretches. So in this case, 2 times f of quantity x minus 8, there's no b term in front of the x minus 8. So in this case, b doesn't exist. We don't have a stretch in that direction. So 3 is reflecting. And what we do to check for reflecting, describe that is, remember if you look at our steps up above, the question was, is A negative or is B negative? And if either or both of those are negative, that's when we get reflections. So we just said B is not existent, it's 1, actually is what it is. That's not a reflection. And 2 is positive, so there's no negative in front of our 2, so we actually don't have any reflections. So we can come up and check that off. Last one, vertical translations. We're looking for that K term, which is at the end. Here we have +4, which means we have a vertical. No, you know what? I'm going to do it this way. Here's how I would write it. If I was a student writing my answers, I would just say shift up 4. And that's all there is to it. So 4, check, done. We've got steps 1 through 4. Then we can move on. With B, what you'll notice right away, we're trying to get this to say x minus h here. And right now, we do not have that. What we have is 6x minus an h term. That doesn't work. So in order for this whole process to work correctly, we have to get to standard form. Right now, our standard form isn't quite met because we have a 6 in front of our x before we subtract it from our h term. So the first thing we got to do is rewrite this whole equation to match the standard form x minus h. In order to do that, we need to factor a 6 out to get x by itself. So we're going to pull a 6 out of this x minus h term. And if we pull a 6 out of the front, we would factor it out of the 12, and we get 6 times the quantity x minus 2. Now we actually have our standard form, and we can look at this. Now, something that might be helpful for you, we can go back and do it to A, but for now, like I said in class, what I do before I even start these, typically, and I'll do them in the order in which we learned them above. So that's actually A, H. Okay. So I find it super helpful. Sometimes it's so easy of a problem or like quick of a problem you don't need to do it. But for all of these intents and purposes, I'm going to do it for all of these. So what I do is I identify all the coefficients out front. Then I can look at my transformations. And you'll see how helpful that is in later examples too. But in this case, A is our out front term. Well, it's just negative f. So there's an implied 1 out here. So A is actually negative 1. Our h, so x minus h, it's not 12. Please do not write 12. It is x minus 2, so h is just 2. Our b term, now that we've factored out a 6, our b is 6. And our k, well, we don't have anything plus or minus at the end. So k, we say is 0. So if we look at this, this might be an easier way for people to describe it too. So if we go to step 1, let me erase my. If we go to step 1, it says horizontal transition. Okay, so that's for h. Well, here's our h right here. We have a shift right 2, because h is 2. And done. Stretching or shrinking, that happens on our a's and our b's. So we actually have, well, we have a term for a -1, but our stretch would be by a factor of 1, and that isn't a stretch, so or a shrink or a compression. So we're just going to leave our a in terms of describing the stretch out of this. But we do have a b term. So we have a b term, which is a horizontal stretch by, now, if you remember our vector for this, go up here, b, it says horizontal stretch by a factor of 1 over absolute value of b. So our b is 6. Therefore, our horizontal stretch by a factor of 1 over absolute value of b. So stretch by 1/6. Okay, so we've got our a and our b terms. Reflections. Here we actually do have a negative on the a. There's no negative on the b, so we don't reflect across the y-axis, but we do reflect across the x. So we take care of our negative signs on our a and b. And last but not least, our vertical translation, but we don't have one. Our k is 0. Therefore, we have no shift up or down. So, example done. If you were to look at these examples here, I can get you started. Example C, we have again, we are not in standard form. We are not in x minus h standard form. So we need to get this whole thing translated to be 0.75 f of, I'm going to pull the full negative 1/3 out times x minus, now in this case, we pulled a 1/3 out of the front, we factored out a 1/3. So in order to get back to this 1/3 x plus 4 by factoring out our negative 1/3, we actually need to place a, oops, no, that's a minus. Okay. I had it right there. X minus 12. And then keep your -8. Don't forget that vertical shift. So if we double check our work, negative 1/3 out front, if we distribute it, we get our negative 1/3 x, and then negative 1/3 times negative 12, that does give us our positive 4. So that does get us back to what we started with. But the reason we do that is now we have x minus h. We have x minus 12. We have a, h, b, k. 8. B is negative 1/3. H is 12. And A is. So that would be how you get that one started. Same thing here. We would factor out a term. In fact, we would factor out negative 5. So if we factor it out, negative 5x matches. And then negative 5, negative 3 is plus 15. That matches. So now we have our x minus 8. We're good to go. So I would recommend, if you take the time, you can check your work on those again. But second video, I'm going to stop again. We're at 11 minutes here. I'll do a couple of specific examples here in part 3, and then we'll be done.